Welcome pre-cal students to the homework help video for this assignment here in front of you. I'm going to go ahead and go pretty fast on this video. As you can look here, I have already pre-written everything, okay? So I'll go pretty fast. So just pause the video as much as you need to, okay? Let's go ahead and start off with number 7. We are going to find the cosecant of 2 theta. The cosecant of 2 theta. Let me say this right off the bat here. We have no trig identity for cosecant of 2 theta, but remember, the reciprocal of cosecant is sine. So really, I can do a bunch of work and find the sine of 2 theta, okay? And then when I get that answer at the end, I can just flip it, okay? And that will be the same thing as finding the cosecant of 2 theta, okay? So with that in mind, let's go ahead and get started, okay? I'm going to go ahead and find the sine of 2 theta instead of the cosecant of 2 theta, okay? Now next, I'm going to make my substitution here. If you look at your trig identity sheets, you will see that the sine of 2 theta is the same thing as 2 sine theta cosine theta. Okay? Now next, I'm going to find this missing side over here, which is 5, by using Pythagorean's theorem. And then once I find this missing side, I know that the sine of theta is 3/5 by using my right triangle over here, and the cosine of theta is 4/5. Now, if I put the 2 over 1 and I do all my multiplication, I will get 24 over 25. Okay? Then, though, remember, 24 over 25 is what equals sine 2 theta. And I want cosecant of 2 theta, so if I flip that, I will get 25 over 24, which is the correct answer. Okay? All right, moving on to number 17. We're going to solve this equation, and we do have a domain. Okay? So keep that in mind at the end of the problem when we're writing our final answers. Okay, did not mean to do that. Okay, the first thing we're going to do is if you look at this problem, we've got an issue here. We have sine of 4x and sine of 2x. So even if we were to bring this over to the other side, sine 4x plus 2 sine 2x equals 0. You could not factor or combine these because one is sine of 4x and one is sine of 2x. Okay, so that's not going to help. So what we're going to do is we're going to take sine of 4x and we're going to work with that a little bit, okay? So here's sine of 4x. Now, watch carefully what I do. I'm going to go ahead and rewrite 4x as 2 times 2x. Now, 2 times 2x is still 4x, okay? However, now I'm calling my 2x u. You know how you like to have this for your double angle identities? You like to have sine of 2u. Well, that's what I'm doing here, only u is going to be 2x, okay? So don't miss that. U is going to be 2x, okay? Now, next, sine of 2u would be 2 sine u cosine u. Okay, that's a substitution for my double angle. And now for u, everywhere there's a u, I'm going to put 2x. So 2x, 2x. So sine of 4x equals all of this. So now I can pick all of this up and put it in place of sine of 4x. And you know why that's a big deal? Because look what I have now. I have sine of 2x, cosine of 2x. All of my angles are going to be in terms of 2x. Okay? Alright, so here we go. I'm going to pick it up and put it up here like I said. And then I'm going to bring down the rest of the equation. And so now this is gone and I have this. Now, what I'm going to do is bring the negative 2 sine 2x over and make it positive. So it's positive now. Brought this over, made it positive. And now I'm going to factor out a 2 sine 2x from both terms. Here's a term, here's a plus sign, and here's a term. So factor out a 2 sine x, and you're left with this. So now you have one group here you can set equal to 0, and one group here you can set equal to 0. Okay? So there we go. Now for this one here, I'm going to divide both sides by 2. For this one here, I'm going to bring the 1 over and make it a negative 1. So here we go. Go ahead and do that. And now I'm left with this here. Okay, so what angle, when I take sine of it, do I get 0? Well, those angles would be, I'm sorry, I just got a little extra room there, so there we go. The angle would be 0 and 180. Okay, now what angle, when I take the cosine of it, gives me negative 1? Well, 180. So what I did here, students, I'm trying to solve for x. What I did is I solved for 2x, okay? So I have 0 here, so 2x equals 0, okay? So divide both sides by 2, and x equals 0. There's one answer. Now take this 0, add 360 degrees to it. Now we're going to say 2x equals 360. Divide both sides by 2 and you're left with 180. Okay? That's another answer because it falls in your domain. Now take 360 and add 360 to it and you have 720. Divide that by 2 and you get 360, but 360 does not work because notice we have a parentheses here, which means not including 2 pi or not including 360. Okay? So here's two answers for 0. Now let's take 180. 180 does not equal x, 180 equals 2x. So 2x equals 180. Divide both sides by 2 and x equals 90. So there's one answer. Now take 180 and add 360 and you'll get 540. So 2x equals 540. Divide by 2 and you'll get 270. And 270 does fall within my domain. And now take 540, add 360, divide by 2. Believe me, you'll be way outside your domain, okay? Now, we could take 180 and do all that again, but we'll get the same two answers, so there's no need. So there's our four answers. So really, we'll write our answers like this. 0, pi over 2, pi, and 3 pi over 2. Okay? Moving on to the next problem. Here we go. All right. Now for number 21, the instructions say to use the double angle formulas to rewrite the expression. Okay? So here's what we're going to do. If you'll look at your double angle expressions, you'll notice that you have cosine of 2u equals 1 minus 2 sine squared. Now we have 4 minus 8. If I just could make this a 1 and just make this a 2, then I can make a substitution. Well, I really can. Because look, if I take this expression and factor out a 4 right here, pull out a 4, 4 times 1 is 4, 4 times negative 2 is negative. If I factor out a 4, look what I'm left over with on the inside. That matches this perfectly. And what does this equal? Cosine of 2u. So I'm going to put cosine of 2x in place of this. And now 4 times cosine of 2x is 4 cosine 2x. Okay? Pretty simple. All right, moving on to this problem here, number 27. Now, they want us to find the sine, cosine, and tangent of 2u. So here we go. First of all, let's go ahead and draw our coordinate plane here. We realize that we're in the second quadrant because of this right here. Greater than 90, less than 180. And we also could fill in our triangle here because we knew secant was 5 over 2, which is hypotenuse over adjacent, and using Pythagorean's theorem, we found this third side here. Okay? Now, having done that, let's go ahead and find sine of 2u first, okay? So the trig identity substitution is 2 sine u cosine u, okay? Next, sine of u is square root of 21 over 5, and cosine of u is negative 2/5, all right? So we're doing pretty good. Now, multiply all these together, put the 2 over 1, and you'll get this right here. So there's one answer. Now let's take a look at cosine of 2u. Now there's 3 substitutions that you can make for cosine of 2u. Any one of those will work fine. I just chose this one. Okay? No certain reason. So here we go. Cosine of u would be 2/5, and sine of u is square root of 21 over 5. Notice they're both squared because of the squared right here. Next, I'm going to square this fraction and get this, square this fraction and get this, bring down my negative sign, and now subtract the 2, and I will get this right here. And that is the correct answer. Okay? All right, tangent of 2u. Well, the substitution would be this right here. 2 tangent u, 1 minus tangent squared u. And then next, I'm going to put for tangent of u, negative square root of 21 over 2. And square root of 21 over 2 right here. Should be negative, actually. There we go. But it doesn't matter because we're going to square it anyways. But let's go ahead and continue on. And so we take this times this gives us a negative square root of 21. And now watch carefully, students. When you square square root of 21 over 2, first of all, you get a positive. When you square a square root, you get the 21. And when you square 2, you get 4. So you have 1 minus 21 over 24, which is what we have here, okay? So next, I would have negative square root of 21 over negative 17 over 4. And then, of course, if you take the bottom fraction, flip it and multiply it by the top, you will get this right here, which is the answer. Okay? So there we go. Moving on to the next problem, number 33. Okay, students, moving on, number 33. We are going to use the power reducing formulas to rewrite the expression in terms of the first power of cosine. Now, this is probably going to be the longest problem that we do, okay? So take some really good notes and pause the video as much as you need to. All right, here we go. First of all, I'm going to take cosine to the fourth power and rewrite it as cosine squared, okay? Cosine squared times cosine squared. Next, I'm going to make these substitutions. If you look at your trig identity sheets, you will see this equals this equals this, and this equals this, okay? All right, moving on. Now do your multiplication carefully. Take this top times this top, and you will get this right here, and 2 times 2 is 4. Now we have to take this fraction times this fraction, okay? So here we go. When you take this numerator here times this numerator here, you will get all 4 of these terms, and 4 times 2 is 8. Now, we're not done because we still have cosine to the third power and cosine to the second, okay? So with that in mind, I really don't want this denominator here. It's going to be really messy. So what I did is this. I factored out a 1/8, okay? And that left me with all of this here. And now I'm ready to make a substitution here and a substitution here, okay? So here we go. So for cosine squared, I put this. And then notice I had cosine to the third power, so I really kind of rewrote this as cosine squared 2x, cosine x, okay? Or cosine 2x, sorry. Which is the same thing as cosine to the third power. Now look what I did here, guys, look. My u was 2x. So when I took 2 times u, I have 4x. And notice my u right here was 2x, okay? So if my u is 2x, when I multiplied it times 2, I have 4x here. Please don't make that mistake and forget to do that, okay? Now watch what I do next very carefully. Please watch carefully. What I did next is I took this in here and I broke it down to 1/2 plus 1/2 cosine of 4x. Same thing inside of here. I broke these two terms up into two fractions. 1/2 plus 1/2 cosine 4x. Okay? There's a reason for that. Alright? It's going to make it a lot easier later when it comes to simplifying. Okay, so what I did next is I took my negative signs and I multiplied them through the two parentheses. Here and here, here and here. Okay? And it left me with this here. Okay, students? Now, watch what I do next. I'm going to take all of this and bring it up top. That's nothing new, okay? The same thing I just had. Now I'm going to combine like terms. Like here's a like term here, positive 1. Here's a like term, and that's the last one. So I combine those. Plus, I can combine a cosine of 2x and a negative half cosine of 2x. So when I combine my like terms, I come up with this, okay? Now notice every term has a 1/2 in front of it. 1/2, 1/2, 1/2, 1/2. So I already have a 1/8 outside. I factor out a 1/2, and that leaves me with 1, with a 1 here, negative 1 here, and a negative 1 here. And now multiply these two together, and you finally have your final answer, okay? And I know that I'm finished because I have all of my cosines written in power of 1, and so that's as far as I can go, okay? All right, moving on to number. Let me hold on 1 second, guys. Let me move this mimeopad here. And here we go, moving on. Okay, number 37. We are going to find the tangent of theta over 2 using this triangle here. Now, first of all, here's my substitution, okay? Tangent of theta over 2 equals this. Now, next, for cosine u, well, I had to find this missing side. So using Pythagorean's theorem, I found the hypotenuse, which was 17, okay? Now, next, for cosine of u, I put 15 over 17. For sine of u, I put 8 over 17. And of course, I got these two answers here from my triangle over here. Next, I simplified the numerator. 1 minus 15/17 is 2/17. Then take the bottom fraction, flip it, multiply it times the top, and you'll get 2/8, which is 1/4, okay? And that is the final answer. Okay, moving on to number 47. Well, the first thing I did here, well, the directions tell you to use your double angle identities to solve, okay? So watch this carefully. First thing I did is I made this into degrees, and you get 67.5 degrees, okay? So next, I said to myself, okay, I'm going to multiply this by 2, and I'm going to have sine of 135 over 2. Now, students, I didn't change anything. The sine of 67.5 is the exact same thing as 135 over 2, because 135 divided by 2 is 67.5, okay? So now I have this, and now I can use my trig identities. Now, remember something. How do I know what quadrant I'm dealing with, okay? Well, you look at your u over 2. Your u over 2 is 135 over 2. And when you simplify that, you get 67.5, which means we're in the first quadrant. So, what is sine in the first quadrant? Well, it's positive. So, I know that when I take my square root here in a second, like this, I'm going to have a positive sign right here, okay? Alright, so here's the trig identity. 1 minus cosine u of 2. Now, u is 135, so 1 minus cosine of 135. Now, we've done a bunch of these, so I'm not going to go into detail where I get the cosine of 135. You guys should know how to draw your reference angle. You're left over with 45 degrees, and cosine is negative in this quadrant, okay? So the cosine of 135 is negative square root of 2 over 2. So 1 minus negative square root of 2 over 2 would be this. Now watch carefully what I did here. I took this 1 and I made it 2 over 2, okay? And then minus the minus is plus. So 2 over 2 plus square root of 2 over 2 would be 2 plus square root of 2 all over 2. And then this number here, I just put it over 1, so I have 2 over 1. Now in a second, I'm going to take this, bring it up top, flip it, and then multiply these two together, okay? And when I do that, I'm going to get this right here, okay? So I flip 2 over 1, I get 1/2, multiply them, 1 times the top is the top, 2 times 2 is 4. Now, I do not know the square root of the top, so I leave it alone, but I do know the square root of 4, so I make it a 2. And there we go, the 4 became a 2, and I'm finished, okay? Now let's try the cosine of 135 over 2. And the cosine, well, once again, we're in the first quadrant because we're dealing with 67.5, and cosine is positive in the first quadrant. So I know I'm going to use the positive outside of the square root, okay? Now, next, I'm going to realize for u I put 135. So 135. And then I take the cosine of 135 and I get negative square root of 2 over 2. Now this time it's a little different. Instead of having minus minus, I have plus minus. Okay, so next I'm going to put this 1's going to become 2 over 2. So 2 plus a negative, or 2 minus square root of 2 all over 2, then all over 2 over 1. I'm going to take this in a second, flip it, and multiply it times the top. Okay, and when I do that correctly, I will get this right here. 2 minus square root of 2 over 4. Now I do not know the square root of the top, but I do know the square root of the bottom. So I'm going to leave the top alone, and I will take the square root of 4, which gives me 2. And I'm finished, okay? Alright, tangent of 135 over 2. Tangent of 135 over 2, we're going to use our substitution here. And this is our trig identity. And now cosine of u would be cosine of 135 and sine of 135. And if we do our work and find those, we will see this cosine of 135 is negative square root of 2 over 2. The sine of 135 is positive square root of 2 over 2. Okay? Now we know how to make this 2 over 2. And we have minus minus, which is plus, so we're going to get 2 plus square root of 2 over 2 all over square root of 2 over 2. Okay? And we're going to take this, we're going to flip it, and we're going to multiply it times the bottom. And when we do that, we're going to get this right here. Okay? This right here. Let's go back and look at it again, okay? 2 times 2, 2 times square root of 2. And then 2 here times square root of 2. We'll give you this here. Now, all of these outside numbers here are reduced by 2. Okay, they can all be reduced by 2. All of the outside numbers. So you're left with this. Now, we do not want the square root, so we're going to multiply the top and the bottom by the square root of 2. Okay, so here we go. we're going to multiply the top and the bottom by the square root of 2. So square root of 2 times this, square root of 2 times this, and square root of 2 times this. If we do that correctly, we come up with 2 square root of 2 plus 2 all over 2. Now, this is an outside number, and this is an outside number, and this is an outside number, so we can reduce all of those 2's by 2, and we're left with square root of 2 plus 1 all over 1, which you don't have to put. Okay, so there we go. Moving on now to number 58. Now this one was really tough, so please pay attention. They want us to go backwards and write, use the half angle formulas to simplify this. The problem is this doesn't match any of your identities. So here's what they suggested. You're allowed to multiply a fraction by anything as long as you do it to the top and the bottom. So we're going to multiply the top of this fraction by 1/2 and the bottom of this fraction by 1/2. Okay, so you're basically putting this over 1 and putting this over 1. You're multiplying the top and the bottom by 1/2. I'll show you why in a second, okay? When you do that, you get this right here. 1 minus cosine 8x over 2, 1 plus cosine 8x over 2. Now, next, the reason you did that, if you'll look at your trig identities, you're going to see this. You're going to see, well, first of all, we can take this big radical and we can split it up into 2 radicals. Remember, anytime you have a radical over a whole fraction like this, you can split it up into 2 radicals. Okay, that's an old algebra 2 rule that you guys should know. So we're going to split the square root up. Okay, now if you look at your double angle identities, no, your half angle identities, students, look at your half angle identities, you will see that we have a substitution for this and a substitution for this. Okay, and here they are. 1 minus cosine 8x2 is sine of 8x over 2. 8x, students, is your what? Your u. And 8x here is your what? Your u. Okay? So I have sine of 8x over 2, cosine of 8x over 2. Okay? Now, next, I can take 8x over 2, 8x over 2, and make those 4x. Okay? So 4x, 4x, so sine of 4x, cosine of 4x. Now, sine over cosine is tangent. So next I have tangent. Now that's good enough for me. On a test or a quiz, that's perfect. Okay, the back of the book has this for their answer. They put negative on the outside, and they put absolute values around this. Let me show you why they did that, okay? What they were saying to you is whatever comes out of this has to be positive. Okay, and here's why. Because all of this came from inside a radical. We all started with this. And you can never take the square root of a negative number. So that's why they put the absolute values around it. You do not have to do that if you don't want to. This was totally acceptable here for me. Okay? But that is why they had those in the back of the book, in case you're wondering. Okay? All right, moving on for number 61. We're going to solve this equation. Now, obviously we have a problem with a cosine of x over 2 and a sine of x, so we're going to make a substitution. Okay? So there it is. Now we're not sure which sign to use here, so we just put them both. Now, watch what I do next. I don't want this radical, so I want to square it to get rid of it, but I better move the sign over first to the other side. Okay? So I'm going to take the sign and move it to the other side. There we go. Now, I did that so I can square this side and square this side. Okay, and the reason I'm going to square both sides is to get rid of the square root. Whenever you square a square root, it gets rid of the square root. So if I square a square root, I'm left with the inside, the radicand. And by the way, the plus minus is gone because I squared the whole side. Over here, I squared sine, so I get sine squared. Now I'm moving along really well. I'm going to multiply both sides by 2 to get rid of my fraction. So multiply this side by 2. Multiply this side by 2, and we get this. Now I'm doing really well, but I still see that I have a cosine and a sine. So I probably need to make a substitution to get rid of this sine squared, okay? So I'm going to make the substitution here. Sine squared is the same thing as 1 minus cosine squared. Now I can take my 2, multiply it through, and I'm left with this right here, okay? Now let's move everything to one side and get it equal to 0. There we go, okay? If you need to pause the video and see how I did that, feel free to do that, okay? But listen, students, I'm sure your heart's not being mean to you guys, but I told you the very first week of school we're going to go over factoring very thoroughly. And then later when we get into factoring and probs, I was not going to reteach you how to do that, okay? So I will say this to you. You can rewrite this like this, okay? And then factor that. And then when you're done, put the cosines back in. If you do that correctly, you will come up with this right here. And I will not take time to go over that again, how we do that, okay? I'm sorry, but we've learned that in the past, all right? So now we take each group and set each group equal to 0, okay? We bring the 1 over and make it negative. Bring the 1 over and make it positive and divide by 2. So we're left with this right here. And if you look in your book, I should have put this up here. We did have a domain, okay? And this is the domain right here. They gave this to us. So what angles will give us negative 1 when we take the cosine of those angles? Well, 180. And what angles will give us a positive 1/2 when we take the cosine of an angle? Well, cosine's positive here and cosine's positive here. It's going to be 60 and 60. So it would be 60 and 300. Okay? And then if you write those radians, you'll get this right here for your answer. So not too bad, okay? Let all that sink in, and we're going to move on to the next problem, number 65, okay? Number 65 says to use the product of some formulas to write the product as a sum or difference, okay? So if you'll look in your trig identities, you will see that first of all, we're going to call this U and this V, okay? Now secondly, we're going to realize that when you have cosine times sine, it equals this right here. You'll see this whole expression here. You'll see that on your trig identity sheets, okay? So where all my U's are here, I'm going to put 4 theta. Where my V's are, I'm going to put 6 theta, okay? So hopefully you can see where I get 10 theta right here. This looks like 100, but it's 10 theta because 4 theta plus 6 theta is 10 theta. And hopefully you can see where I get negative 2 theta. 4 theta minus 6 theta is negative 2 theta. Now, remember this old identity we learned, guys. Sine of negative theta equals negative sine of theta. So whenever you're taking the sine of a negative number, a negative angle, you can put a negative out front, but there's already a negative there. So it looks like this. Negative and then negative sine of 2 theta. So the negative sign is basically moved out front. Okay, that's not true for all trig identities, but that is true for sine, okay? And now we have a negative times a negative, so your final answer would be positive right here, okay? Look all of that over and see if you have any questions, okay? Number 65. Okay, moving on to number 71. Now, it's the same thing again in 71. We're still in the same section, and they want us to use the product to some formulas to write the product as a sum or difference. So we still have cosine times sine. Look at this whole expression here. This whole expression as U, and look at this whole expression here as V. Okay, and trust me, that will work. So this is my U, this is my V. Now, cosine times sine has this trig identity right here. Sine of U plus V minus sine of U minus V. Okay, so here we go. Watch this carefully, guys. For U, I'm going to put theta minus pi. Plus, for V, I'm going to put theta plus pi. Okay, and when I do that, my thetas cancel out, my pi's cancel out. I'm left with 2 theta. Okay, now let's go back to here. For U, right here for U, I'm going to put theta minus pi. Now be careful, it's minus, so minus V, and V is theta plus pi. So look what you have. You have theta minus theta, so they cancel out, and you have negative pi minus pi. So negative pi minus pi is going to give you negative 2 pi. And now we have the same thing we had before. Sine of a negative angle is the same thing as negative sine of the positive angle. So I'm going to bring this negative out front here and make this positive right here. Okay, so there we go. And then negative and a negative gives me a positive. All right, and we are moving on. Here we go. Number 81. Now the directions for 81 say to use the sum to product formulas to write the sum or difference as a product. So I have a cosine plus a cosine, okay? Now if you'll look, we're going to call this our x, and this our y. Okay, and also if you'll look, cosine plus cosine has a trig identity of this right here. This whole expression here equals this whole thing down here. Okay, now look carefully what I have, guys. Watch this. Okay, look. For x, I'm going to put 6x, plus for y, I'm going to put 2x. So 6x plus 2x is 8x, divided by 2 is 4x. So this whole thing here becomes 4x. Okay, now over here I have 6x for x minus 2x for y. Well, 6x minus 2x is 4x, and 4x divided by 2 would be 2x. So I have a 2x here. And that's it. There's nothing else you can do. So we did it. We took two trig functions that were written as a sum and we wrote them as a product. Okay? So doing pretty well. All right, moving on to number 85. Now, same thing. We're going to use the sum to product to write a sum or difference. Now, this whole expression here is going to be my x, and this whole expression here is going to be my y. Okay? All right, so here we go. Now, this whole expression here, if you look in your trig identity section, equals this here. Okay? All right. Now, for my x, right here I'm going to put 0 plus pi over 2 for my x. And then plus, for my y, I'm going to put theta minus pi over 2. Now look, positive pi over 2 and negative pi over 2 cancel. We have theta plus theta, so this whole thing here becomes 2 theta. Now come over here for x, I'm going to put theta plus pi over 2 minus, and then for y, I'm going to put theta minus pi over 2. Now watch your signs. You have theta minus theta. They're going to cancel out, okay? You got pi over 2 minus a negative, so plus. You got pi over 2 plus pi over 2. That's like a half a pi plus a half a pi. That gives you a whole pi, okay? So you end up with, and that's not correct, so hold on. Where did I get 2 from? Did I not divide by 2? I did not divide by 2. I apologize, guys. My fault totally. Let's go back over here. We had theta plus theta. That's 2 theta over 2. So 2 theta over 2 is going to give you theta. Okay, now over here, we have a half a pi plus a half a pi. That's pi. But then we're dividing by 2, pi over 2. So we end up with pi over 2. I forgot to divide each of these by 2 here, and I apologize. So you end up with this right here. Okay? Look all that over. Back up the video if you need to, okay? Pretty simple. All right, number 93. This one's really simple here. I'm not sure why they put this in here, but we'll end with a couple easy ones. So here we go. First of all, we know what the sign of, we're going to quickly find these missing sides here of this hypotenuse here, and we can find this one here. Okay, so we'll do that quickly, and we get 5 for this length here, and we get 13 for this whole length right here. Okay? All right, moving on. Now they want us to find the sine of this unknown angle here, which is opposite over hypotenuse, so 5/13. And then the cosine of B is going to be adjacent 4 over hypotenuse, 4/5. Multiply those together, and you have your answer, 4/13. Okay, moving on to number 101. Let's see what we have here. The tangent of 2 alpha, I believe this angle is called, I believe that's what it's called. What is called A. So 2A. Well, first of all, we're going to have to use a trig identity, so we make a substitution like this. Now, for tangent of alpha, here's alpha right here. Here's the triangle I'm going to use right here. Everybody see that? Okay. So tangent of this A would be opposite over adjacent, 5/12. So I'll put 5/12 here, and I'll put 5/12 here squared because I have tangent squared right here. Okay, now here we go. 2 times 5/12 would give me 5/6, and if I square this, I get 25 over 144, and then 1 minus that is going to give me 119 over 144. So I have 5/6 over this fraction here. Take this fraction right here, flip it, and multiply it times the top. And if you do all your simplifying, you will come up with 120 over 119. Okay, 120 over 119. So I hope this homework video has been a help to you guys, okay? A lot of work on some of these, but you really need to be familiar with these trig identities, okay? If you have any questions, don't hesitate to call or email.